Myself Megha Rathod. I am teaching maths in LPSAVANI VIDHYABHAVAN. Today continues chapter number 1, number system. Today's topic is representing real numbers on the number line. Suppose we want to locate 2.665 on the number line. We know that this number lies between 2 and 3. But it is very difficult to locate this number directly. We have to use magnifying glass. So we call this process of visualization of representation of numbers on the number line through a magnifying glass as the process of successive magnification. This process, for understanding, we have to explain example number 11 from textbook. So everyone, take out your textbook. Page number 16, example number 11. Visualization, the representation of 5.37 bar on the number line up to 5 decimal places. That means here 5 decimal places, the meaning of this is after decimal there are 5 digits. So our number is 5.37777, 4 times 7. Here you can see this. Once again we proceed by successive magnification and successively decrease the length of the portions of the number line in which 5.37 bar is located. First we see that 5.7 bar is located between 5 and 6. In the next step we locate 537 bar. Divide this portion of the number into 10 equal parts and using magnifying glass to visualize the 5.37 bar lies between 5.37 and 5.38. To visualize 5.37 bar more actually, we again divide that portion 5.37 and 5.38 into 10 equal parts, and then we can see 5.37 bar lies between 5.377 and 5.378. Now to visualize 5.37 bar till more actually, we divide the portion between 5.377 and 5.378 into 2 equal parts and visualize the representation of the 5.37 bar. Now we see the figure 1.14. In figure 1.14 fourth, note that 5.37 bar is located closer to 5.3778 than to 5.3777. Here first number line you can see draw 5 to 6 and our number is lies between 5.3 and 5.4. Now next number line 5.3 to 5.4 and our number lies between 5.37 to 5.38. Third number line 5.37 to 5.38 and our number lies 5.377 to 5.378. Now fourth, 5.37 to 5.378. So here you can see the number is 5.377. But our number is a 5 decimals. So next line we have to draw to locate this 5.37777. 4 times 7s we have to locate. You draw the number 5 number line 5. Okay, now to see more than locate the numbers, exercise 1.4. Exercise 1.4, question number 1. Visualize 3.765 on the number line using successive magnification. So here first number line I draw 3 to 4 and our number lies between 3.7 to 3.8. Next number line 3.7 to 3.8 and our number lies between 3.76 to 3.77. And now last here the number line we have to draw 3.76 to 3.77 and our number is 3.765 we can see. Same thing for the question number 2. Visualize 4.26 bar on the number line up to 4 decimal places. Here our number is 4.2626. So here we draw 4 to 5 number line first. Second number line 4.2 to 4.3. And third number line we have to draw 4.26 to 4.27. And fourth number line we have to draw 4.262 and 4.263, and our number lies here 4.2626 we can find. Thus we can draw this type of the number line and we visualize the decimal number on the number line. Now we start exercise 1.5. Question number 1. Classify the following numbers as rational or irrational numbers. First number, 2 minus root 5. Here 2 is a rational and root 5 is an irrational number. We know that the difference of the rational and irrational number is always an irrational number. So we can say that 2 minus root 5 is an irrational number. Number 2, 3 plus under root 23 in one bracket minus under root 23. Here we simplify it. 3 plus, we remove the bracket first and write 3 plus under root 23 minus under root 23. Plus minus under root 23 cut and we get the 3. So here we can see 3 is a rational number. So we can write that 3 plus under root 23 in bracket minus 23 under root 23 is a rational number. Third number, 2 into root 7 upon 7 into root 7. Here 2 into root 7 upon 7 into root 7. Root 7 cut because both are in denominator and numerator. And we get 2 upon 7, which is a rational number. So we can say that this number is a rational number. Fourth, 1 upon root 2. Here is a rational number. Here 1 is a rational number and root 2 is an irrational number. We know that division of a rational number and irrational number is always an irrational number. So we can say that 1 upon root 2 is an irrational number. Now fifth, 2 pi, where 2 is a rational number and pi is a rational number. We know that the product of a non-zero rational numbers and irrational numbers is always an irrational number. So we can say that 2 pi is an irrational number. Question number 2. Simplify each of the following expressions. To solve these sums, we have to use the operations which we learnt. First number is 3 plus root 3 in one bracket, second bracket 2 plus root 2. So here we simplify it with 3 multiplied by in one bracket 2 plus root 2 plus root 3 multiplied by in bracket 2 plus root 2 and simplify it. 3 multiplied by 2 plus 3 multiplied by root 2 plus root 3 multiplied by 2 plus root 3 into root 2. And then we get the answer 6 plus 3 root 2 plus 2 root 3 plus root 6. Now second number. In bracket 3 plus root 3, in second bracket 3 minus root 3. Here our operation is a plus b and a minus b. So we can write directly a square minus b square. So here we can write 3 square minus root 3 square. 3 square is equal to 9 and root 3 square is equal to 3. So 9 minus 3 is equal to 6. Third number, root 5 plus root 2 whole square. Here our operation is a plus b whole square. So is equal to a square plus 2ab plus b square. So now here we can write root 5 square plus 2 into root 5 into root 2 plus root 2 square. Root 5 square means 5 plus 2. Root 5 into root 2 means root 10 and plus root 2 square means 2. Then we can get the answer 7 plus 2 root 10. Fourth number, root 5 minus root 2 in one bracket. Second bracket, root 5 plus root 2. Our operation is a minus b, a plus b is equal to a square minus b square. Here we write root 5 square minus root 2 square is equal to 5 minus 2 is equal to 3. To simplify this, we use the operations. Now question number 3. To read the question, everyone take out your textbook, page number 24. So, here, question number 3. Recall, pi is defined as the ratio of the circumference, C, of the circle to its diameter, D. That is, pi is equal to C by D. This seems to contradict the fact that pi is irrational number. How will you resolve this contradiction? Here, answer is, when we measure the length of a line with a scale or any other device, we only get an approximate rational values. So, we cannot decide that in C and D, which one is irrational number. So, either C or D is irrational. That means C by D is irrational and hence pi is irrational. Thus, there is no contradiction in the saying that pi is irrational number. Now, we have to learn under root decimal number on the number line. We already learnt irrational numbers, decimal numbers, locate on the number line, but now we have to learn to represent under root decimal number on the number line. To learn this, we have to do question number 4. So, now we start question number 4. Question number 4, represent under root 9.3 on the number line. So, how can we draw? I read the steps and you understand. And I draw the figure and explain it in the Zoom classes. First step is draw a line segment AB is equal to 9.3 units. Now extend AB up to point C such that BC is equal to 1 unit. You can see in the figure. Here AC is equal to AB plus BC is equal to 9.3 plus 1 is equal to 10.3 units. Draw perpendicular bisector of AC meeting at O, means OA is equal to OC. Here we can find. Now O be the midpoint of AC. Draw a semicircle with center O and radius OC. Draw the perpendicular BD on AC which intersect the semicircle at D. The distance BD is equal to root 9.3 unit. Draw an arc with the center B and radius BD which intersects the number line at point E. So this E represent under root 9.3 on the number line. Here we understand how can we locate under root 9.3. Now question number 5. Rationalize the denominator of the following. First number 1 upon root 7 is equal to 1 upon root 7 multiplied by root 7 upon root 7 is equal to root 7 upon 7. Second number 1 upon root 7 minus root 6 is equal to 1 upon root 7 minus root 6 multiplied by root 7 plus root 6 upon root 7 plus root 6. Because here our denominator is root 7 minus root 6. So we multiplied it with root 7 plus root 6. Now we simplify it and we can get 1 upon, we can get root 6, 7 plus root 6. Number 3. 1 upon root 5 plus root 2 is equal to 1 upon root 5 plus root 2 multiplied by root 5 minus root 2 upon root 5 minus root 2 is equal to root 5 minus root 2 upon root 5 square minus root 2 square. So, root 5 minus root 2 upon 5 minus 2 is equal to root 5 minus root 2 upon 3. This is our answer. Now for number 1 upon root 7 minus 2 is equal to 1 upon root 7 minus 2 multiplied by root 7 plus 2 upon root 7 plus 2. Because here in denominator is root 7 minus 2. So we multiplied with root 7 plus 2. Now root 7 plus 2 upon root 7 square minus 2 square. Then root 7 plus 2 upon 7 minus 4. So our answer is root 7 plus 2 upon 3, because 7 minus 4 is equal to 3. Here we completed our chapter number 1.5. Now chapter number 1.6 we also discussed in the previous videos and PDF. I also write full exercise in the PDF and explain in the previous video. So now I am not repeating it, and today we completed our chapter number 1 full, and I want you write full chapter in your fair book properly. And now we will start chapter number 2 in next session.